Hey, sorry about the timing on this. So some condensing rules, and expansions are the same pretty much, but condensing is a little bit more challenging. So the first one that was on that paper, I don't know why this is bleeding through, is 4 ln x plus 2 ln x. Well, there's a couple of ways we could do this. It depends on what your teacher wants. So because they're like terms, I can really just add this, right? So this is 4 plus 2, which is 6. So I could say this is 6 ln x, right? Or we can rewrite this as 6 log x. It's the same. Now, whenever there's a coefficient in front of something, that really kind of comes back over here and becomes an exponent, right? So the 6 would be over the exponent of x. So we could say that this is ln x to the 6th power, or we could say this is log x to the 6th power. Either one's fine. So she's probably going to want this, right? That's what I would want if I was simplifying this problem, but either of those should work too, okay? Log x plus log quantity x plus 1. When it's a plus in the middle, this is the addition rule. So it's going to be multiplication. So what we're going to do is the logs condense into one log. So we'll just write log. And then in parentheses, we're multiplying x times x plus 1. So I'm going to show you what it looks like first, right? But we really can distribute that x to both of those terms. So because we're multiplying one thing by a binomial. So the final answer for this is log of x squared plus x, right? Because again, I'm distributing the x to both those terms. So this is the final answer, right? Oops. Yeah, because we have to multiply. So there we go. Sorry, my brain just stopped working. All right, last one that I saw in the paper. We have the power rule and we have the quotient rule, because quotient means subtraction. So first, we want to get the power rule, because power has to come first, because that's like the first number we see. So the 3 in front coefficient becomes the exponent of x, and the 7 coefficient becomes the exponent of this x. So rewriting this is going to be log base 5, x to the 3rd power, minus log base 5, x to the 7th power, right? But now we have the quotient rule. So the quotient rule just says we'll do the log with the base, and then we'll do this value over this value, right? Because it's a division problem. So log base 5, x to the 3rd over log base 5, x to the 7th. That's not really how you want to write it, though. I just wanted to show you for completion. You just want to write one log base 5. So log base 5, x to the 3rd over x to the 7th. That's probably fine, that answer. I don't know if she's going to want you to simplify the x to the 3rd over x to the 7th. If she does, because that kind of is a little bit more complete, you'd have log base 5 over x to the negative 4th power, right? Because 3 minus 7 is negative 4. So this is probably fine. But again, either one of these should be okay, right? So hopefully that helped. Expansion is exactly the same thing, just reverse, right? So when you see a division problem, know that it's going to end up to be subtraction, like side by side. If you see an addition problem, it's going to be multiplication. Or if you see a multiplication problem, you're going to have to break it apart. And then this one you can just simplify. And then obviously the power rule, we've seen that a couple times. The power rule is if you have a coefficient in the front, it becomes an exponent on the back. Okay, see ya.